Welcome to Boiler Logic, the home for power engineers, boiler operators, and facility professionals. In this video, we'll explore one of the most widely used steam generators in industry, the Firetube boiler. Firetube boilers have been used for over a century to produce reliable steam for heating, sterilization, manufacturing, and power processes. We'll look at how Firetube boilers work, the path of fire, water, and flue gas, and identify the major components operators must understand to run them safely and efficiently. The Firetube boiler was one of the earliest successful steam generator designs. It became widely used during the Industrial Revolution, powering factories, locomotives, and ships. Early designs like the Cornish and Lancashire boilers evolved into modern horizontal Firetube boilers used today. While watertube boilers dominate large power plants, Firetube boilers remain extremely popular in hospitals, pharmaceutical facilities, universities, food plants, and small industrial operations because of their simplicity, reliability, and ease of operation. A Firetube boiler works on a simple principle. Hot gases flow through tubes surrounded by water. The heat from combustion transfers through the metal tubes and into the surrounding water. As the water absorbs this heat, it eventually boils and produces steam. Unlike watertube boilers, where water flows inside tubes, in a Firetube boiler, the hot gases travel inside the tubes while water surrounds them. The process begins at the burner, where fuel, usually natural gas or oil, is mixed with air and ignited. The burner produces a controlled flame inside the furnace, also known as the combustion chamber. This is where the hottest temperatures in the boiler occur, often exceeding 2000 degrees Fahrenheit. The flame and hot combustion gases then begin their journey through the boiler. The hot combustion gases travel through a series of passages called passes. Most modern Firetube boilers are 3-pass or 4-pass designs. First pass, hot gases travel down the length of the furnace. Second pass, the gases reverse direction and flow through a bank of fire tubes toward the front of the boiler. Third pass, the gases reverse direction again and travel through additional tubes toward the rear. During each pass, heat is transferred to the surrounding water. By the time the gases exit the final pass, much of the heat energy has been absorbed by the boiler water. The fire tubes are completely surrounded by water inside the boiler shell. As the water absorbs heat from the tubes, it begins to boil and form steam bubbles. These bubbles rise to the top of the shell where steam collects in the steam space. From there, the steam exits the boiler through the steam outlet and is delivered to the plant for heating, sterilization, or process use. The burner controls the fuel-air mixture and flame that generates heat. The gauge glass allows operators to visually verify the boiler water level. Maintaining proper water level is critical for safe operation. The water column houses level controls and safety devices that monitor water level inside the boiler. The pressure gauge indicates the internal steam pressure of the boiler. Operators constantly monitor this reading to maintain safe operating conditions. The safety valves are the boiler's ultimate protection against overpressure. If pressure rises above the set point, the valves automatically open to release steam and prevent an explosion. Blowdown valves remove sludge and dissolve solids that accumulate in the boiler water. Regular blowdown helps maintain water quality and prevent scale formation. After transferring their heat, the flue gases exit the boiler through the stack, safely venting combustion products to the atmosphere. Firetube boilers remain popular because they offer simple design and operation, high reliability, compact packaged installation, good response to load changes, lower maintenance compared to complex boiler systems, This makes them ideal for hospitals, pharmaceutical manufacturing, food processing plants, universities, and small industrial facilities. Understanding the design and operation of Firetube boilers is essential for every stationary engineer and plant operator. From combustion in the furnace, to heat transfer through the tubes, to steam production inside the shell, each component plays a critical role in safe and efficient operation. This has been Boiler Logic's 3D explanation of Firetube boilers.